We have to find maximum, minimum and inflection points for the given function. We will start from the domain. The domain for our function will be all real numbers because we can take to third power every real number. We can subtract, multiply, add. So the domain, our function y, is all real numbers. To solve this problem, we will use the first derivative test. So we need first derivative. Y prime is equal. Derivative of x to third is 3x squared minus derivative of 3x squared is 3 times 2 times x to first power. I don't need to write. And derivative of constant is 0. So we don't have to write this. So y prime is equal 3x squared minus 6x. We have first derivative. Now we have to solve equation when y prime is equal 0. If and only if 3x squared minus 6x is equal 0. We have quadratic equation to solve. I will factorize 3x, so will be in parentheses x minus 2 equals 0. So when the left side will be 0, when 3x equals 0 or x minus 2 will be equal 0. So we have x equals 0 and x equals 2. We have critical values. Next, we will draw the graph of our first derivative. We have x. We just sketch this function because we have quadratic function. The graph will be parabola, open up because the coefficient before x squared is positive. We have roots 0, 2. This is our graph. Next, we check when our derivative has positive values and when our first derivative has negative value. This part is above x-axis, so has positive values. This part is under x-axis, so has negative values. And this part is above x-axis, so here we have positive values. So now we see that at 2, the derivative change sign from positive to negative. When we change sign from positive to negative, it means at this point we will have minimum. And when derivative change sign from negative to positive, we have maximum. Now we have to find this point. We have first coordinate x. So let's start from 0. We have x equals 0, so we have to find the y coordinate. We just copy our function y equals x to third minus 3x squared plus 5, and we have to calculate y of 0. So we replace x by 0, so it will be 0 to third minus 3 times 0 to second plus 5. So y of 0 is equal 5. So we have first point 0, 5, and in this point we have maximum. This is our first solution. Now we have to find minimum. So at this point we have x equals 2. So we have our function. We can rewrite this. Y equals x to third minus 3x squared plus 5. And we have to replace x by 2. So y of 2 is equal 2 to third power minus 3, 2 to second power plus 5. So y of 2 is equal 8 minus 3 times 4 is 12 plus 5. So y of 2 is equal 8 minus 12 is negative 4 plus 5 is 1. So we have point on our minimum. So 2, 1 is point for our minimum. So we have minimum. Now we have to find if our function has inflection points. To find inflection points, we need to find the second derivative. We have first, so we have to just calculate derivative of the first derivative. So we have second derivative will be derivative of 3x squared is 3 times 2x minus derivative of negative 6x is 6, negative 6. So y, the second derivative, will be 6x minus 6. Next, we have to find when our second derivative is equal 0. Y, second derivative is equal 0 if and only if we have 6x minus 6 is equal 0. We have to solve this equation. I will move negative 6 to the right and divide both sides by 6. So x is equal 1. So now we have to check if in this point our second derivative change the sign in a small distance from x equals 1. To find this, the easiest way, I think, is to draw our function 6x minus 6. We have root x equals 1, so let's draw x number line. And we have linear function, have x equals 1. Linear function, the graph will be straight lined, and positive coefficient tell us that this line going up. We see that for x equals 1, we change sign from positive value because this part is above x-axis, so has positive values, and this part is under, so has negative values. We change from positive to negative values. So we can say that for x equals 1, we will have inflection point. So now we have to calculate the value for our function for y of 1. So it will be, we just have to replace x by 1 in our y function. So it will be 1 to third power minus 3 times 1 to second power plus 5. So y of 1 is equal 1 minus 3 plus 5. So y of 1 is equal 1 minus 3 is negative 2 plus 5 is 3. So we have inflection point 1, 3. This is our inflection point. Let me write this. This was graph for the second derivative, 6x minus 6, and this graph was for the first derivative, y prime equals 3x squared minus 6x. So this is my solution.